From 26, we're going to add these two rational expressions, and notice the denominators are always the same. They're the same. So we already have a common denominator. So all we need to do here is write a big fraction bar and write that common denominator, and then just add the left numerator to the right numerator. So it's going to look like this: 2x plus 5 plus the x minus 6. Okay, we're going to take the left numerator, add the right numerator. Now let's just combine terms here. So this is going to give us 2x and x, right? 2x plus x is 3x, plus, and then 5 minus 6 is a minus 1. Oh, so we're going to get a minus 1 here. So minus 1 over x minus 4. And that one's done. Now, let's use the same idea here in problem number 27, but instead of adding, we're going to subtract. We're going to take this rational expression, subtract this rational expression. And again, you notice we already have the same denominator, so there's not going to be too much involved here. We're going to draw a fraction bar, write that common denominator, and then take the left numerator, 4x plus 3, subtract the right numerator. Now here's the thing. We have to be careful here. This is a minus. So I want to be sure to subtract all of this. I want minus all of it. So I need parentheses to capture all of it. So minus, be sure you write parentheses if you're subtracting. And now let's distribute that minus sign all the way through. So it's going to look like this now. 4x plus 3 minus 3x minus 4, right? Minus 3x minus 4 all over x minus 1. And then 4x minus 3x, that's just an x. And then we have 3 minus 4, that's negative 1. And the denominator is x minus 1. And those are going to cancel. And we're going to end up here with just 1. Right? Now remember, when you draw these cancellation lines, there's really a 1. X minus 1 will go into x minus 1 one time. So this will work as long as x is not equal to, now just take us back here one step. What can x not equal? Just in that denominator, x can't be a 1. So as long as x is not equal to 1. So what we're doing is taking this set of instructions, replacing it with this set of instructions, and we can do that as long as x is not equal to 1. You can see here we have two different denominators, so we need to get an LCD, and we'll get the LCD by factoring this denominator. So let's just rewrite here. We'll go with x minus 19 over x and x. Let's use 5 and 3 for that 15, so we'll use a 5 and a 3. How about a plus 5 of plus 3 plus x minus 7 over x plus 5. And now we can see the LCD, right? Everything's factored. We can see the LCD. We've got the x plus 5. We've got the x plus 3. Now, the x plus 5 appears here and here, but the highest power to which it appears is just 1. If, for example, this was a squared here, we'd use x plus 5 squared. If this one over here was, say, to the 6th power, we'd use it to the 6th. But they're both just to the first power, so we just use it to the first power. So the LCD is x plus 5, x plus 3. Now, here's how I like to do these. A little bit different than the way it's presented in textbooks. I'm going to write a big fraction bar, and I'm just going to write LCD here. And I'm going to keep writing LCD until we can't do anything else to this. I'm going to simplify as much as possible. Then when I'm done, then I'll actually write the LCD. So I'm going to add two fractions. Now, I'm changing the denominator, maybe. Now, if look at this new denominator, compare the original fraction to the new one. Look at this old denominator, the original denominator, and look at the new one. Well, how about here, factored form? Any change? So if I write this down here, this denominator is the same. There's no change. So if I don't change the bottom, I don't have to change the top. So the top is just going to be x minus 19. Minus a plus, Now plus, now let's look at this fraction over here. The original denominator was x plus 5, but now we're making it x plus 5 times x plus 3. You can see just by comparing here that this x plus 5 is being multiplied, there it is being multiplied by x plus 3. So in the denominator, the original x plus 5 is being multiplied by x plus 3, so to keep things balanced, we're going to have to multiply the top by x plus 3. So we're going to have x minus 7, x plus 3. Now let's simplify here. We're going to get x minus 19 plus, all right, multiply, x squared plus 3x minus 7x minus 21 all over the LCD. This is going to give us x. Well, let's actually combine here. This is a good time to start combining here. So what are we going to get here? We're going to get an x squared, so we'll get the x squared. Now what about x's? We've got x plus 3x, 4x, and then minus 7x is minus 3x. Did I get that right? X, there's 4x, minus 7x, yeah, minus 3x, and then negative 19, minus 21, minus 40. Now I'm going to write LCD because I can still factor that. Let's factor that numerator, write it over the LCD. X and x, let's use 8 and 5. Okay, and how about a minus 8 plus 5? Now, here's where we are. I'm going to get rid of this LCD. And actually, because I can't do anything else here, right? I can't do anything else. We've factored. So write the LCD. The LCD is up here. So actually, just write that. It is going to be x plus 5, x plus 3. And now you can see that the x plus 5s cancel. That one cancels with this one. And we're left with x minus 8 over x plus 3. So x minus 8 over x plus 3. And this will work as long as x is not equal to, now just follow it one step back. What's going to make this denominator 0? Negative 5 and negative 3. Negative 5, negative 3. So what we're doing now, just keep in mind, we're taking this set of computing instructions, replacing it with this more compact, more efficient set of computing instructions.